You are watching this video because you need to fix a high coolant concentration as you top up your coolant tank. Our tank is about 3/4 full, and fortunately, it's reasonably clean. The coolant log shows that deionized water has been used during top-up, so pH and water hardness should be just fine. Check the concentration of your coolant with a refractometer. Be sure to check out our Tools of Coolant video for more information about this essential tool. The concentration of our coolant is 16%, definitely placing it on the rich side. The logical thing to do is dilute this rich coolant to get the concentration back between 6 and 10%, where it will perform correctly. Here are a couple of ways to do this that will work with most any brand of coolant. For high concentrations, under 20%, run the coolant down to half full during normal use, or remove coolant until half full. Then add 5 gallons of deionized water to a bucket and mix in 7 ounces of concentrate. To make a 1% mixture, and add this to the tank until full. If the tank is already below half full, add the same 1% coolant until almost full, and then recheck your concentration. You may need to top off with a richer mixture or just finish up with the 1%. So for our 16% tank that we have here, just as we showed in the graphic, we remove coolant until half full, setting aside the rich coolant for later. Now all that's left to do is fill the remainder of the tank. As we just mentioned, we'll do this using a low concentration mixture. Hold on a minute. Why aren't we using plain water to fill the remainder of the tank? Well, here's the reason. New concentrate contains additives known as emulsifiers. Their purpose is to help the water and concentrate mix completely. These emulsifiers allow the coolant mixture to remain stable and well mixed during machining. The problem is that over time, the additives in the coolant become depleted during use, resulting in emulsifiers that are less effective. Meanwhile, tramp oil and dirt are accumulating, making it difficult for water to mix in correctly. Topping off with 1% buckets instead of plain water helps everything mix together completely. So, now that we know why we need these 1% buckets, we'll start making our top-up coolant using 5 gallons of deionized water. You might ask, why do I need to use deionized water to top up my tank? Can't I just use tap water instead? Over time, the water in the coolant evaporates away. But if tap water is used, the hard minerals in the water do not evaporate. Each time you top up the tank with tap water, a new batch of minerals is added to the mixture. After a few rounds of this evaporate and top-up cycle, well, you've got a tank packed with minerals and your coolant may be ruined. We don't want to make that mistake, so once our deionized water is in the bucket, we mix 7 ounces of concentrate into each 5-gallon bucket of water we add to the tank. When the tank is full, check to be sure the concentration is correct. The concentration in our example is just above 8%, just as expected. By reducing the tank volume to half full and adding the 1% mixture, we diluted our 16% solution in half to get about 8%. This method works great for fixing rich concentrations under 20%. But what if your concentration is even richer, like somewhere between 20 and 30%? Simple. Just multiply your tank full height by 0.3. This calculation gives you the exact measurement in inches to reduce your coolant level down to 30% full. Remove coolant until you get down to this measurement and fill with 1% coolant buckets. This will return any size of tank back to a concentration between 6 and 10%. Let's put this method to the test with 3 examples using different tank sizes and different concentrations. We have a 55-gallon tank at a concentration of 25%, a 75-gallon integral tank at a concentration of 30%, and a 150-gallon tank at a concentration of 22%. For each of our tanks, we start with their respective tank full heights. Then we multiply each of these numbers by 0.3 to reduce the level of coolant down to 30%. Now we remove the coolant from the tanks. Save the rich coolant for use later on. We add our 1% coolant mixture to fill each tank and mix it thoroughly. Now here's what we find when we check the concentration with our refractometer. All 3 tanks have been returned to a coolant concentration between 6 and 10% and are ready for use. For more information on topping up a lean tank, mixing new batches of coolant, and the tools of coolant maintenance, see our other videos in this series. Thank you for watching.